All right, so today we will be working on section 3.5, which has different kinds of algebra functions and composition of functions. So first thing we want to talk about is notation, because you're probably not used to notation like this. So, for example, if you want to add two functions, this is, if I say f plus g of x, it's really the same as f of x plus g of x. And for everything, we're going to just ignore the domain because the domain is not really part of this section. It's part of this section, but you have no homework assigned to it. So it's not part of the course. So everything about the domain of these functions, do not worry about. We're just talking about notation now. So if you have plus, we just separate into two functions. I mean, you can think of it like it distributes, but it's not really the same. It's just a different notation. So again, we don't care about the domain, but we want to find, it says, so basically, it says determine the domain, but that's not what we're going to do. So let's just, but it is telling me what h of x is. So h of x is equal to f minus g of x. Hold on one second. Okay. And then this is equal to f of x minus g of x. Okay. So basically, if we want to know what the function is, we can say it's equal to, and we put everything in parentheses just to begin with, because that minus has to, remember, it has to distribute. So we can say this equals x squared minus 5x. I distribute the negative, and I get minus 2x plus 9. And that equals x squared minus 7x plus 9. Okay? Now, I have h of 3. This is A. And B says, find h of 3. So h of 3, actually, let's do it like we always do. Well, let's do it, actually, I don't know if, I think I showed you this. I had to do these recordings out of order, by the way, so this we did in the last section, yes. But everywhere there's an x, we're just going to put a parentheses. And now we're just going to substitute 3. So h of 3 is equal to 3 squared minus 7 times 3 plus 9, which is equal to 9 minus 21 plus 9, which is equal to negative 3. 9 minus 21 is negative 12, plus 9 is negative 3. And that's really basically it. So first we find the function by just subtracting them, then we plug in 3 for if we're trying to find out what the function equals. Okay, so let's just do it again. Again, we're not going to do the domain, but we are going to do everything else. So h of x is equal to f plus g of x, which is the same as, that's what B's really actually asking. So I'm gonna, this PowerPoint I had to grab from somewhere else because the PowerPoint from Pearson is incorrect. So don't look at the PowerPoint from Pearson, but we'll just do this one. So we have a f of x plus g of x. Yes, so equals f of x plus g of x, which is really what B is asking, but we wouldn't ask it in that way. And then evaluate h of 3. So we'll do C here. We can say h of whatever is equal to, and first thing we want to do, actually, let's do it like this. Here, this is x squared plus, and then I don't really need parentheses here, the square root of x minus 2. So I have h of whatever is equal to whatever x is squared plus the square root of x minus 2. So what are we plugging in? We're trying to find h of 3. So 3 goes in all those parentheses. And I just get this is equal to 9 plus the square root of 3 minus 2 is 1. Square root of 1 is 1, which equals 10. So hopefully this is pretty easy for you guys. And I'll do -1 as well. This is where the parentheses really make a difference. So whenever you're doing this, if you have a negative, make sure you have those parentheses. Plus the square root. Okay. And what we want to plug in now is -1. So I have -1, -1, -1. And I can see that this is equal to 1 plus the square root of -3. So this is undefined. We can't find the square root of -3, so we wouldn't, so there's no solution for that one. Okay, undefined or no solution. All right. Okay, products and quotients. Again, don't worry about the domain. But what we want to do is we want to say for all functions f and g with domains p and q, the product and quotient are defined as follows. So basically, you just, if you have a multiplication sign there, you just multiply. If you divide, you just divide. And you also do have to make sure, one really important thing, even though I crossed it out, is that g of x cannot equal 0. Because then I'm dividing by 0, which is undefined. So let's do, so we won't determine the domain, but we will find h of x. So for a, h of x is equal to f times g of x, which is the same as f of x times g of x. Okay? And that's actually what b is. So we're not going to do b. And then the last one we want to do is from the results of part b, which is really what this is. This is actually the results of part b. Because a was to find the domain. So we'll say this is b. Okay. So C, we want to evaluate h of 2 and h of 4. So all I'm really going to do is h of 2, and I'm going to stop doing that different color thing, because I think at this point you should have it, is equal to, well, f of x is equal to the square root of 1 plus x, but x is 2, right? And then times the square root of 3 minus x, where x is 2, okay? And if you like that other way, you can do it for yourself, but all I've done is now, this is f of x, or this is f of 2, and this is g of 2, okay? And when I multiply it together, I get the square root of 3 times the square root of 1, which is the square root of 3. Okay? And if I want to find h of 4, that's equal to the square root of 1 plus, now this is x, so let's just say this is x, this is x. And so x is 4. So we have 1 plus 4 times the square root of 3 minus 4. which is equal to the square root of 5. And again, this is the square root of -1, which as far as we're concerned, because we're only working with real numbers, this is again undefined. Or we can say no solution. Okay, so that's basically, I mean, I think that part's pretty simple. And then when we do division, again, we're not going to determine the domain, so we're going to leave this out. But since it's division, I'll just call the new function is what we're making h of x. So here we say h of x is equal to f divided by g of x, which is equal to f of x over g of x, as long as g of x does not equal 0. Okay, so let's do it. So what we're going to do is say h of x is equal to, well, f of x is x to the third minus 3, and I'm getting it from right here, minus 3x squared plus 2x minus 6, and g of x is x minus 3. Okay, so that's B, and C says find h of 3. And I'll show you a different way if this one's more comfortable for you. So we know it's going to be f of 3 divided by g of 3. And what I could do is I can evaluate f of 3 and g of 3 before I even begin. So let's see, where can I do that? I'll just do that here. So I can say f of 3 is equal to 3 to the third power minus 3 times 3 squared plus 2 times 3 minus 6, which is equal to 27 minus 27 plus 6 minus 6, which is definitely equal to 0. So now we know f of 3 equals 0, and g of 3 is equal to 0 as well, right? Because it's 3 minus 3, which equals 0. Okay? Now, we're just going to say, we're not going to get it fancy here. We're just going to say h of 3 now is going to equal 0 over 0, which is, again, no solution. Okay, but let's find out what h of 0 is. So we'll grab this. All right, so now let's do h of 0, which is equal to 0 cubed minus 3 times 0 squared plus 2 times 0 minus 6. And of course, this is 0, this is 0, this is 0, so I just get minus 6. You know what? Let's do it like this. Let's say, let's define f of 0 first. And then let's define g of 0 is equal to 0 minus 3, which is equal to minus 3. So h of x is equal to f of x over g of x, which means h of 0 is equal to f of 0 over g of 0. So f of 0 we said was -6, and g of 0 we said was -3. So our final answer is 2. So now that's interesting, right? When we plugged in 3, we got something undefined, and when we plugged in 0, we got a value that is defined. So that it's not that x can't be 0. Okay, so here we've shown that x can equal 0, but g of x, the denominator, cannot equal 0. And that's the important thing to take away from here. Okay, let's do this. Actually, I think we did something like this before, but a review won't hurt. So I did, first thing I always say to do is everywhere there's an x, put just parentheses. So this is going to be a. And then I want g of -5. So I plug in -5 and I get 25 minus 3, which equals 22. Okay. For b, I have g of something equals that thing squared minus 3. And if I do b, it says 5t. Oh, 5t. So I plug in 5t for x. And this is now going to equal 25t squared minus 3, which is our final answer. We can't combine like terms, right? There's no like terms. And then C, we have g of x is equal to, x squared minus 3. And now we plug in t minus 4. So now we have t minus 4 squared minus 3. This is really the same as t minus 4 times t minus 4, which is going to equal t squared minus 8t plus 16. And then I'm going to subtract 3. Here, I'll do it in red just to keep it a little separate. Okay. And now our final answer would be t squared minus 8t plus 13. And so that's how we evaluate different functions. Now we want to talk about the composition of functions, which basically means what we're going to do is we're going to take a function. Well, let's read the definition. Given two functions f of g, the composition is defined by, notice that has an open circle. It's not a dot. This means composition. This means multiplication. So they're different. Okay. And another way to write this is, so if we have f composed with g of x, you can read it as f of g of x. Okay. So when I think about it, this little circle, I think of like an O, and I say f of g of x, just like it is. And what's happening is the domain of the composition, well, again, we're not talking about domains and ranges. So let's forget about that. But it is important to understand what the composition means. So if I have f of g of x, I'm going to first evaluate what's inside the parentheses. So these, though these are square brackets, we consider them parentheses. It's just a different type of way to say parentheses. So that's f of g of x. So we say, okay, g of x. First, we need to figure out what g of x is. So we input our x, right? Whatever the function is, we have some input. It goes through g of x, right? Goes through this machine, and out comes g of x. whatever this machine is, right? It could be the square root, it could be something squared, it could be absolute value, it could be a lot of different things. It doesn't matter what it is. Whatever g of x is, and like, let's say x is 4. So we put 4 into the squared function and out comes 16. Okay, so here, let me write that down. Just as an example, not always. So let's say we're going to input 4, and we're going to say g of x is equal to x squared. And what's going to come out is 16, right? So now we've evaluated, here, let's do it like this. So we have f of g of 4. And, sorry. And then I'm going to say, well, that equals f of, well, we know that, let's see, how do I want to say this? So g of 4 is equal to 16, right? Because I'm plugging in this 4 into my x squared. So then I now want to know what f of 16 is. That's why my output right here, which is g of x, is my input into this new function we call f of x, right? And let's say f of x is equal to, what do we want to say that's equal to? Trying to think of a good function that you know that would be helpful here. I'm sorry, I'll just square it again. What the heck? So I square it again. Now f of x and g of x are both x, they're both squaring x, right? So now what's happening is this is on my new function, and f of 16, well, if x is 16 here, that means I have 16 squared, which is 256. So what I've done is I've passed it through one function, and then the output of that function, I pass it through another function, and that's what the composition means, okay? So for example, if I want to find the composition of these two functions, what would I do? Well, I first start off by saying f composed with g of x is the same as f of g of x, okay? And then, I think I should do this in colors. So this is f of g of x. So what I'm going to do next is I'm going to plug in what g of x equals. Well, g of x is equal to 3x plus 2. Okay, so now I've plugged in my g of x function into now I plug it into my f of x function. So f of something is equal to the square root of that thing minus 4. And if I plug in 3x plus 2, I get 3x plus 2. So now I just evaluate. This is equal to the square root of 3x plus 2 minus 4, which is equal to the square root of 3x minus 2. So that's the answer to f composed with g of x. What do you think? Do you think if we go the opposite way, it'll be the same? Well, let's find out. So we're going to start with g composed with f of x, which is equal to g of f of x, right? Well, first thing I do is I plug in my f of x into this function. because I'm going to replace f of x with f of x. And so I get f of x minus 4. Oh, so I was going to use colors. I didn't. So this is equal to the square root of x minus 4. And now I plug in that into my g of x. So g of whatever is equal to 3 times x plus 2. And I'm going to plug in for x my x minus 4, square root of x minus 4. And so my final answer becomes 3 times the square root of x minus 4 plus 2, which is not the same. These are not the same. So it does make a difference which way you do the composition. Now, even though it's not a question, let's ask, what is f composed with g of, let's make up a good number here. F composed with g of 2 would work. So this is equal to, well, we know that f composed with g of x is equal to that. So f composed with g of x of 2, all I do is I say this is equal to the square root of 3 times 2 3 times 2 minus 2, which is equal to the square root of 6 minus 2, which is 4, which is equal to 2. So we can see that if I plug a value in here, I have to evaluate, I could actually evaluate first. So for example, let's do B a different way, because there's more than one way to do pretty much everything. So let's go to B here. Get it. All right, so now we're going to say this is B, and this was G composed with F, but now let's say what's G composed with X of 6? Well, that's equal to G of F of 6, okay? Now, again, we can evaluate using just X's, and we can say that this is equal to, this was G of F of X, which is the same as G composed with F of X. So again, we can just plug in 6 now because we've already found out that this is what that equals. So we could say this is equal to 3 times the square root of 6 minus 4 plus 2, which is equal to 3 times the square root of 2 plus 2. Now, what might be an easier way to do this problem, if you are given a value, okay, so like if you're given a value and you're asked, what is F composed with G of, let's say 3, then, yeah, that'll work. Then what we can say is this is equal to F of G of, this is just another way to do it. This might be an easier way to do it if you're given a number, because I can find out what G of 3 is first, right? G of 3, I just look at my G of X and I say this is 3 times 3 plus 2, which is equal to 11, okay? And now, really what I want to know is, since this is going to be now equal to f of 11, right? I can just plug in f of 11 is equal to the square root of 11 minus 4, which is equal to the square root of 7. So again, I could evaluate them first and then plug in a number, or did I plug in the same number? No, I used 2. Here I use 3. Okay, if I use 2, well, let's do it again with 2 just to show that it's the same. So if I say, what is f composed with g of 2? Well, that's the same as f of g of 2, right? So I first want to know what is g of 2. And I go and I find g of 2 is equal to 3 times 2 plus 2. 3 times 2 plus 2, which is 8, right? And then I want to know what f of 8 is, because now g of 2 is 8. So I plug it in here and I get, so I plug this into the f. So I get the square root of 8 minus 4, which is equal to the square root of 4, which is equal to 2, which I do believe is what we got when we did it the other way. So g of 2 is equal to 2, and there we have it. So these are two different ways. You might find the second way that I showed you, where you plug in a number, if you're given a value, a lot easier than evaluating with just x's, but it's really up to you, especially when you have something like f composed with g of some function and you have to square it. It might be easier if you were given a value to just plug it in first and then evaluate. So for this one, again, I'm going to add a C and a D. I'm going to add a C. I'll add a C and a D, because once I find my composition, I want to know what it is when I have 2, or if I have the reverse, what I have. We can just use 2 again. So we'll use 2 for both of them. I'm pretty sure 2 will work fine for both of them. Okay. And I believe this is our last slide. Anyway, our last slide. No, we have one more after this. Okay. So let me just copy this. All right. So the first thing I want to do is I want to do A. Okay. And A has an X. So this becomes F composed with G of X is equal to F of G of X. Okay. So now the first thing I do is I plug in my G of X with my G of X. So this is equal to F of 2 over X squared, right? And now I have my F of X is equal to 3 times X divided by X minus 1. And everywhere there's an X now, we get 2 over X squared, 2 over X squared, 2 over X squared. Okay. So now this is going to equal, well, I can multiply this. This is equal to 6 over X squared over, and now we have 2 over X squared minus 1. But I'm going to change that 1 to a common denominator, which is X squared. So I'm going to subtract. I'm going to multiply this by X squared over x squared. So I'm going to subtract x squared over x squared. Let me do it a little different here. So I'm going to multiply this. I'm going to turn that into x squared over x squared, or multiply it by that. And I get 6 over x squared over 2 minus x squared over x squared. And then I can do my keep, change, flip, which gives me 6 over x squared times x squared over 2 minus x squared, right? And my x squareds are going to cancel. And my final answer here would be 6 over 2 minus x squared. Okay, so that's A. Now, actually, I'm going to next do C. Okay, because if I were to do C, let's do this. Actually don't need this here. No, I probably did. Let's move it down. Okay. So I know that A, which is f of g of x, is equal to 6 over 2 minus x squared. So what is C? So let's do C, because I can just now plug 2 into there. Okay. So I could just say here, I get f composed with g of 2 is going to equal 6 over 2 minus 2 squared, which is equal to 6. Let me try to get rid of this little bar at the bottom. Yeah. I think I can move any of that. So that's, yeah, so that's equal. Here, let me, I don't want to do this here. I'm going to do this on the next page. It's too squished. So, okay, so let's just continue. Let's do B next. I think that'll be the better way to do it here. So for B, I have G composed with f of x is equal to G of f of x, which is equal to G of, and then I know f of x is equal to 3x over x minus 1, right? So now I know what I want to do is evaluate G when x is equal to 3x over x minus 1. So again, I say G of that thing is equal to 2 over 3x over x minus 1 squared. Oh, sorry. I was just put a parenthesis squared. No, wait, I'm sorry. I lost track. G is equal to 2 over, yeah, that's right, 2 over x squared. So I have, this is 3x over x minus 1, and this is 3x over x minus 1. And I can evaluate this to be 2 over 9x squared over x minus 1 quantity squared, which is equal to 2 over, and then I have 9x squared. I evaluate x minus 1 squared, and I get x squared minus 2x plus 1. And then I do keep, change, flip. So I get 2 times, and I flip the fraction, right? X squared minus 2x plus 1 over 9x squared, which is equal to, if we distribute 2x squared minus 4x plus 2 over 9x squared. And that is G composed with f of x. Okay, so that's kind of complicated, especially if I was given that, let's do this. Oops, I don't know what I did. So if I was given, if I started out being given that I have those two values are equal to 2, those x's are equal to 2, there's no reason, wait, still not getting everything I want, sorry. Yeah, that should do it. Okay, so here I'm being given, so now I'm doing C, which says f composed with G of 2. Now in this case, it's probably a lot easier to, if you're given C and not asked for what x is, to just do this. Because now I need to find out what G of 2 is, and G of 2 is equal to, oh, you know what? That's not even a squared, but I'm going to make it squared because I'm reading it wrong. Yeah, I read that whole thing wrong. So instead of redoing everything, I'm just going to say that is squared. This is squared. And this is squared. Okay, so everything is squared instead of a comma. Sorry about that, guys. So that's squared. So now G of 2 is equal to 2 over 2 squared, which is 2 over 4, which is 1/2. Okay, and now that I know what f of 2 is, I'm sorry, G of 2 is, I can say f of, and now I'm going to replace this 1/2 because that's what G of 2 is. I just found that out. And that's going to equal 3 times 1/2 over 1/2 minus 1, which is equal to 3/2 over negative 1/2. I keep, change, flip, keep, change, flip, and I get negative 6 over 2, which equals negative 3. So I think this was a lot easier if I wasn't asked for what it is when it's x, and I just have this value, then it's a lot easier to plug the value in first and evaluate. That's what I'm trying to show you. And then we'll do D real quickly. So D is, I need to copy this whole thing again. So now we want to do D. So if I want to do D, then I have G composed with f of 2, which is equal to G of f of 2. So now I have to evaluate f of 2 first. So f of 2 is equal to 3 times 2 over 2 minus 1, which is 6 over 1, which is 6. Okay, and then I plug that in and I get G of 6, which is equal to, and I plug that 6 into the G. So that's 2 over 6 squared, which is equal to 2 over 36, which is equal to 1 over 18. And so it's considerably easier if I'm given a number and I have to evaluate it than if I'm not given a number and I have to do all the algebra with the x, okay? So I wanted to show you that you could first find this and then plug in the twos, or you can just plug in the twos before you worry about using the ones with x. I hope that is clear. This is really not on your homework, so I'm not gonna confuse you. I'm just gonna not do this one. You don't have anything like that on your homework. So I'm just gonna say that's the end, and thanks for watching.